Wave, Mitch, so they know who you are.
Yeah, hi,
There he is. There he is.
hello guys. Good to meet you all.
Mitch, do you have handy the link to the book that you could put into the chat?
Of course I can. Yeah, I'll put that in.
Okay, so Mitch, whenever you're ready,
Yep.
just do a
Super.
little introduction. Tell us a little bit about yourself and about the book, et cetera, et cetera.
Yeah, I'd love to. Thanks, Paul. So yeah, like Paul said, welcome to everyone here. A lot of you are new faces. There's a couple of people I recognise on the call, but a couple of names. But so again, my name's Mitch Jago. I've been in the business in the oil and gas engineering sector for 50 years. I started off as an apprentice in 1974 in London, working for a company that was then called Stone and Webster, that have since changed names over the years. But at the time, they were rather specialists in ethylene, in the design and engineering of ethylene units, because that was pretty big then. Petrochemicals was big in that era. So I worked for that company for 3 years as a piping designer on the drawing boards, um, and then migrated beyond that to other companies and worked overseas for a while in places like Canada and the US and South Africa and Norway and other places. And I and so essentially with the work that I've done over those 50 years and the experiences I had on offshore platforms and onshore facilities, I decided about 7 years ago to put this down in writing. So, in other words, to put a few stories down. It's not a book about the oil price of OPEC, the OPEC sets, and the how well Shell are doing for the first quarter of any year. It's about my experiences as a piping designer on the board, migrating to the CAD machines later on, and it's the book is peppered with a lot of stories of experiences, practical jokes that went on in those days that you'd never dare consider these days. You'd be walked out of the office. I remember someone letting off a fire extinguisher in the office just for a joke, and it covered everyone and everything around him with this filthy liquid, and he just got a finger wagging to stop doing it, and got on with his work. These days you wouldn't get away with that, and of course we have a multicultural environment now. I mean, in 1974, if I was in a drawing office with 30 people, they would be 30 English people, and it's fantastic to see the industry move into such that where we have international representation now. And and all of you that are working in the environment in engineering, you've probably got the same thing now. You're working with people where you'd be in a meeting with 22 people and there'd be 21 different nationalities around you. So that's rather cool. CAD machines, of course, took over from the drawing boards, and we've had to adapt to CAD machines, which on a good sense, that's on one hand, it was a great transition, but on another hand, and I put this in my book quite a bit, it did allow people to make changes more quickly. When you were on the drawing board and you had to make a change to a drawing on your board that you'd been working on for 2 weeks, if someone asked you to move equipment to a different location that affected the piping design around that equipment, you'd go, my God, are you sure you want to do this change? I'm going to be rubbing all this area out here and changing this whole drawing. And there was a lot more consideration that went into that. But nowadays, of course, if someone wants to make a change, they would just come up to me and say, Mitch, we want you to move that equipment there. And of course, it's done a lot easier.
Yeah.
The change is made. But nevertheless, they're much more frequent now because of that ease of making those changes. So yeah, anyway, there's a bit of a summary, Paul, on that. Anyway, hope that helps.
Yeah, that's great. Thanks. Yeah, I definitely agree. just because you can make changes doesn't mean you should. And the ability to make changes relatively easy compared to the past means that you may be inclined to not prepare as much as you would if it was much more difficult to make changes. You can then get into a situation where you're doing design by trial and error, you know. So
Absolutely.
the technology is wonderful. It's great for visualization, but it can also mean that there are downsides to it.
Yeah, very much so. Very much so. And you get people like in those days, you'd if people were going to make a change on a piping drawing, it would be the piping people that made that decision. But not anymore. It's project management tend to no criticism of those folk who have a vital place in our engineering society, but they make decisions these days, and we have to be we're at the mercy of some of that, and the decisions often are made in our business. They're made from a cost related point of view, not so much quality. So we overlook quality much more these days, I think.
Yeah, I agree. Yeah.
Than we used to. And it's all about cost and schedule. Yeah, and I'm sure Kevin and others will be able to support that sort of line of thinking. But yeah,
and a lot, of course, a lot more of the designer's job is operating the tool.
Mm.
Whereas in the past, you learned how to use a pencil and that was it. You knew how to use a pencil for the rest of your life. Now you've got a variety of software packages. If you use one package, you may not be considered for a job to work on a different software package.
Yeah, indeed.
You have to expend extra effort just operating the tool rather than thinking and, you know.
Yeah. And I think and another thing, Paul, one thing I'm noticing on projects these days, unfortunately, is people they're not very comfortable. They're not very happy these days on projects. It's all about, oh, they can't wait till this project's finished type thing. Well, it wasn't like that years ago. We enjoyed projects. We had a team that would stick together for maybe 2 or 3 years to get these projects out the door. And, we'd all celebrate at the end of it, and 1 or 2 of that team would go to site and see it forward. But these days, it is a graft, getting through a project and trying to focus on the quality component more so than the cost and schedule, or equally as a minimum. But I'm seeing a lot of that these days as well. And no apprenticeships these days. Very few in the UK. I don't know any company right now in London that are taking on apprentices. I don't know if that's the same in Montreal and other parts of the world. Are they taking on apprentice engineers for designers and piping guys and stress engineers and designers? Are they doing that?
Not so much from what I've seen. It's as if people are just interchangeable machine operators rather than skilled and talented pencil operators.
Yeah, indeed.
As well, the way projects are run now, with work share and remote, teams aren't actually together.
Yeah, there's less coherence. There's the problem of more difficult communication, misinterpretation, because you're not sitting right next to the guy and you can point to it and say this thing right here.
Yeah,
you have to go around in circles. It makes it much more complicated to discuss things. And
no, that's a good point, Kevin. Yeah, absolutely right there. Yep. And I mean, that's one great thing about the last 20 years. I've had an opportunity to visit places like China and India several times to see these outsourced projects, and they are well-oiled machines. And some of you dialing into this meeting may be part of those teams that are involved in home office project development, and they're doing it. And you need to know you're doing a great job. You are. There's no question about that. but yeah, it does tear up the cohesion a little bit there. But nevertheless, it's a positive side of it.
If I could ask a question,
Yeah.
there was I saw a trend in a lot of foreign countries where engineers, that's people that went to a 4-year engineering program like mechanical engineering or chemical engineering, were practicing piping layout and equipment layout on the tube. There was even a trend for a while where nobody but an engineer would be hired as a piping designer. Then Fluor and other companies began to push back because engineers that were trained as engineers wanted to quit piping design and go into real engineering because they weren't using their math and science skills. They felt that they were, in a lesser position. But SPED's always pushed the idea that piping design has its own body of knowledge. Okay, it's not distinct, but it is a separate center of gravity from engineering. We're not applying math and physics, we're applying ilities, constructability, maintainability, operability, and so on. And so how do you feel about that? Do you feel like the future belongs to an engineer who decides to practice as in piping layout and equipment layout, or do you feel like we're going to have a separate workforce, a separate profession that's going to become a super user, a super layout guy, a super routing guy? What do you think the future belongs to?
No, great, Bill. That's a terrific comment. So, there's two sides of this story, I guess. When you're educated or qualified as an engineer, that specific engineer, Bill, be it, let's say he's a stress engineer, he likes the numbers. He wants to use the Caesar analysis program, and he wants to make sure that everything, the flexibilities, he's in his own little world of science and numbers and engineering. On the piping, one thing that drew me towards the piping design front was the fact that a piping designer needs to know where an electrical building is going to be on a site. He needs to know where an electrical cable tray is on a pipe rack. He needs to know how big a piece of mechanical equipment footprint is going to be, so he can put it in the right position and allow sufficient space around it. And that's one thing about the piping design side of your comment there is what it rings true that piping designers, they need to know a little bit about everything else. They need to know a little bit about a structural design of a platform and how wide a cage is on a ladder and how many ladders and cages he's going to need on the platform so that he can get away and escape any hazardous occurrence on that platform. So he needs to have a fair bit of understanding. One thing I've noticed that projects in the piping lead world, where a piping guy leads up another team of piping guys, it will rarely be a piping stress engineer or a piping materials engineer that leads up that group. It will normally be someone of a background of a design, because it's that person that has that grasp on his own team. He'll know what the stress engineer is doing. He'll know what the material engineer is trying to do, and he'll have a grasp on plot layout and piping design as well, Bill. So I think that's an important part. So I don't think anything's going to change in that world. I think there's a lot of talk these days about the chat BGT component coming in and being able, so someone one day will be able to type in the size of a plot, the number of equipment, the number of lines, and then suddenly within an hour there's a piping layout in front of him. Well, it's not. I don't think that's going to happen, but I think there are people that think that might be on the cards. But I don't know if that answers your question, Bill. But I think there's a I think that there's a need for piping designers going
Well,
forward, very much so.
well, the people who make the AI tools will tell you absolutely we can do it.
Yeah,
Just give us a few $100 million in funding, and then we'll come up with something after 2 years.
yeah, yeah,
So,
exactly right. So there is, I think, I mean, we did have, let's face it, we went from drawing boards with people drawing lines to a 3D modeling where a computer system routed the line for you, right? We did go down there and tracks all the materials. No longer do we do material takeoffs and time-consuming quantities, spreadsheets of quantities. We have that built into our computers' 3D systems now. So yeah, I think there is an element of that. I'm sure it'll creep into the business, but I think I mean, I've just come off a project on a feed project where I had 119 piping people on the feed project for a South Korean petrochemical facility, and to be built by S-Oil, the South African South Korean operator. So yeah, I mean, clearly we needed these people in some form or another. There was no way we could replace them. So yeah, I do feel that we're going to need that. I would like to see more apprenticeships coming for people, for youngsters that are coming out of university. I'm sure there's people on this call right now that are wondering what their future lies, and they're not happy with what they're doing, and they're thinking of going into another field of engineering or something. But yeah, we need more. We need more trained resources, not just trained people on what we call the buttons here, the keyboard, but people that know the background and know that a 2-inch, 2,500-pound ring joint rated ball valve will need 2 people to lift it, and right, and not many people understand that concept and so yeah, so we still need those people, very much so.
No, that is exactly what SPED's specialty is. We don't teach any software. We want to teach the information you need to have in your head.
Yes,
before you start clicking buttons.
Fantastic, and it's good that SPED are supporting that, Paul, and your team, and you've been doing a great job for years, and you're continuing to do that. So I welcome that.
There's a question in the chat here from Kevin. Actually, Kevin, do you want to ask your question, or do you want me to do it? Or?
Oh yeah.
You go ahead, Paul.
Oh, okay. Kevin says, has there been a diminishing of technical skills with the emergence of modeling skills? In other words, I'm using part of my brain to operate the machine. That part of my brain no longer is towards design and layout and conceptual. It's learning the buttons. And
now that's a good, Kevin. Oh, sorry, mate, I missed that question. That was right up there. And so yes, is there a diminishment of technical skills? I think we still need the technical skills, like we just talked about. Modeling is fine, that people can model lines from A to B and have the skill sets to do that. But one thing that they don't do is when someone's got a set of process flow diagrams in front of them, whether they're called P&IDs or flow sheets or whatever, when they've got those in front of them, they will normally, even what we would call senior piping people these days on the 3D systems, they will model one line and then model another line and then model the next one from start to finish. Now, from a technical point of view, what I like to see is that someone has a sketch pad next to them, and they've got an understanding. You walk past their desk, and on their notepad, they've got a rough line shoot of the lines that are going from a pipe rack to a vertical vessel or something. and they've got an idea on where those lines should fit into the big picture before they do any 3D modeling on those individual lines. That's very refreshing to see that, but it's very rare that we do see that, because people just get stuck in to the modeling of that one line. But the quality of that arrangement is going to be by setting out that plot space early on, whether it be a pipe rack and a distillation column with a couple of pumps at the bottom and a reboiler hanging off it. They need to plan that work before they start doing anything in the 3D. But so I don't know, Paul, Kevin. I think there has been a diminishing, but it shouldn't be. We should retain that need for individual quality on the actual what they're doing, on their craft, on their piping design.
Well,
Yeah.
in related to that is, you're talking about doing design sketches and maybe, hand studies, but when you model something in the software, it looks perfect. It looks like it's complete. It's done.
Yeah.
So you don't have that, oh, this is obviously just a little sketch. It's in my head. And then when I'm happy with it, then I'm going to model it. And it's going to, right now, as soon as you start running the line, it looks, someone walking by would go, oh, look, hey, it's finished. We're ready to go for construction right now.
Absolutely.
And then
Absolutely.
I've seen cases where, you start doing detailed design when you don't even have, let's say 90% complete and accurate vendor drawings.
Right.
You're modeling your piping based on, see, here's a picture of what we're going to buy.
Yeah.
You can see the nozzle comes out on this side. Well, just run the pipe and then.
Yeah.
But it's easy to fix later. So, but that's not the point, that it's easy to fix. It's because once you get on a certain path, if you're slightly off by a couple of degrees, by the time you're at your destination, you're off by 3 or 4 miles, right?
That's right. And it's misconceiving, because of that background you've got there, Paul, with that facility there, where it's a typical hydrocarbon facility, probably with some vessels and piping and all that. Now, when you have your first set of flow sheets issued, a piping designer can put all that together on the model, and they go into a model review and everyone loves it. Like you just said, they go, wow, look at this, it's all done. But you haven't got any line size verification. You haven't done any stress work on the systems. You haven't got a vendor on board yet that tells you how the equipment should be. And the compressor that you're going to buy is actually 3 times as big as the piping designer that put it in the model. So yeah, it's a misconception that. So we are deceived on things like that, and we do need this. I mean, brand new projects that I move on now, the project manager, the first thing he wants to do is say, Mitch, we've been on the job a week. There's nothing in the model. You've not modelled anything. Well, no, I haven't modelled anything because we haven't got all the P&IDs yet for the process. We haven't got any utility P&IDs. We haven't got a line list, and all the line sizes on the P&ID are all the same. They all say XX, and so we're not doing anything. But there's a lot of pressure on the piping team these days to get things in the model, and I think that's what you're alluding to, Paul. Yeah. To get things in the model and be able to show the client that we are really moving forward and progress is being made. And great topic of conversation. So yeah, that's good question there. I see a comment there. SPED no longer thinks of piping designers as drafters, but as appliers of their own body of knowledge. Yeah, please comment on whether, and that's what you were just asking, Bill, wasn't it? There, so that's a good point. And you've agreed there, Gemma. Looks like on my company. Yes, I'm agree with William. On my company drafter, just provide some drawing revisions from the designer engineer, so the designer have to understand the company's design standards. Yeah, absolutely right there as well. And then the comment below there, for the greater scale, engineers who practice in piping could really help the proper symphony of projects to finish. Yeah, absolutely. Yeah.
Yeah, well, this is it. In the older days, I think the piping, the non-degreed piping team used to have a lot more influence and power as opposed to now. When the computers and the software came in, it has diminished, in my opinion, the role of the designers, and that it shows. You can see. Well, I mean, you had to have worked in the old way to be able to see, because if you come into it now, that's just the way it is, and it always has been. So,
no, that's right. No, you're absolutely right. Yeah, Clarence,
Yes,
how you
mate.
doing? How you doing, mate?
Oh, not too bad, brother. Not too bad.
Great to see you. Great to see you, mate. It's been a long time, pal. Been a long time.
Yes.
So, to everyone dialing in, this guy Clarence Winter is a legend in piping in Calgary. Anyway, so it was always great to work with you and socialise with you, mate. And you put a great comment down there, and that comment, transposition activities is no longer a part of project design development. And by that you're talking about the line shoots and things, right? On getting stuff. Yeah,
Correct.
we don't.
Yeah.
You're absolutely right. We don't spend enough time to do that and size a pipe rack and all that good stuff.
Mitch, could you explain, because a lot of the people here might not know what a line transposition is?
Yeah, I'll be happy to. So on the back of Clarence's comment there, so for everyone dialing in, if they're all piping people, I'm sure most of, if not all of you are, when you've got a flow diagram that shows lines running from equipment to equipment, they're a schematic, of course. They just show one line in a straight run with maybe a couple of bends in it, and to get the information on the drawing. But of course, it's not a design at all. So that line might have to run from that equipment to that equipment. It might be a 50 meters of run on the plot plan between where that equipment is, and it might have to run on a pipe rack to that equipment. So what you need to do, what a piping designer would need to do to start his work off, is he would do a transposition. So he would take all the big ticket line items on those flow sheets, and on a plot plan in 2D, years ago it would be on a plot plan, and someone will put it on in red pencil. But on a 2D plot, that on an AutoCAD drawing, that piper would put those lines down, and he wouldn't put any fittings. They'd just be straight runs. He'd go from the equipment to the pipe rack. He'd run along the pipe rack. He'd run off the pipe rack to the other equipment, and he'd yellow that off on the flow sheet. And then he'd take the next line. So he's going to start with a 24-inch line, maybe a steam line, and then he's got some 20-inch cooling water return and cooling water supply lines, and he plugs those lines in. So at the end of his exercise, when he's got 20 flow sheets where all the piping is on this transposition or line shoot, he's got a plot plan with all these lines on there. But then he'll be able to look at the lines on the pipe rack, and he'll be able to look at the lines and go, right, well, that's 5 20-inch lines, 4 24-inch lines, 6 4-inch lines, an 8-inch line, a 10-inch line, and a couple of 3-inch lines. And what he'll be able to do is he'll position those lines on the pipe rack. If the pipe rack is 6 meters wide, he's not going to get all those lines on one level. So he's going to go, well, how many levels do I need then? And he's going to work out the number of levels. So not only is he sizing his pipe rack from a width point of view, he's also establishing the number of piping levels that are needed. And then he'll add 1 or 2 levels for cable trays above it. And that's a necessary requirement to size that pipe rack, so his civil structural colleagues can actually start designing that pipe rack structure. So that's, in a nutshell, that's what a transposition is. So great comment, Clarence. Great comment, mate. Yeah. I'll scroll down a little bit there. In your experience, who is responsible for final dimensions of isometric drawings, piping designer or the fabricator? So that's a fairly simple one. It's the designer. There's no responsibility in the fabricator to design that piping system. The piping designer for that system, well, once he's done his transposition and then he models his lines in 3D, when he drops or extracts the isometrics, they will come out of the system and it will look like it will give you a 3D version of the layout of that piping system. Right now, it will then go, I would hope, to a piping checker. But again, sometimes, you know, astute project managers can think they can get by without checking everything, but that's for another conversation. So a piping checker will look at that drawing and he'll go back to the designer and say, look, you got a little bit wrong here, got the wrong valve in there. I think you need to do a little bit of the stress guy might say there's a bit more flexibility required. And at the end of the day, he'll have a system that will get signed off and issued, IFC, and issued for construction, that will mean. And that piping isometric will then go to the fabricator to be built. And that fabricator will build that isometric. And if the piping team have done their job, the fabricator won't have any questions. They will always want questions, of course, and they will always want to catch things that are not right because that's where they make money. And if an engineering piping team screw up, it's the fabricator that makes the money because the questions that come back to the engineering team, they can't write them quick enough. So to answer that question, it's always the piping team that get the dimensions. All right. Now on site, when it's installed on site, there may be other drivers on site at the time that may deem that isometric needs to be changed. But the change will happen from a markup at site, and then it will go back to the design team to be revved up to a Rev 1 or Rev 2 of the isometric. But it is the piping designer that drives that. Are there any guidelines? I've seen greenfield projects with routing errors and the contractor is forced to pick up the difference. Yeah, there are. This is another great point. There are guidelines. So we might have, if you work for a company like Fluor or KBR over the years, or Worley, in fact, they've got systems and work processes in place that tell a designer how we should design that piece of equipment or that valve set. And this might be something like, and this might be a pump discharge line on a 12-inch pump discharge, where once upon a time when that pump discharge was coming out the top of the pump, we would have those valves in a line above that nozzle. But these days now, to eliminate loads on that pump nozzle, we would take that piping off that discharge, run it down to grade, and run those valves in a horizontal and support them from grade next to the pump. Now, what that does, that adds more space requirement to the pump footprint. So by adopting that approach, the two pumps would need to be probably 1.5 meters further apart than they would do if the valves were on the nozzle. So we do have a good company will have work processes and guidelines for things like that. Very much so. So that's good. That's a great question. Next one here. There is so much elementary error in projects that I have been involved in, especially construction stage. Is it fine to think this situation is normal in designer perspective? Oh, blimey, I feel sorry for you, whoever. Fandy, did you write that? Is that your first name, Fandy, or is Harry your first name?
My first name is Andy, and
Andy. Sorry, Andy.
Andy is my middle name.
Oh, right. Okay. So this is a great point. So it does happen. So projects can be set up poorly in the first few weeks, sadly. So these things do happen on projects, without meaning to pour cold water on everything we do. sadly, a lot of projects do. They do experience some hardships these days, for want of a better word. We don't get it right to start with. Often we consider cost and schedule, like we talked about earlier, much more importantly than we do for quality in design. So we don't apply enough attention to that. So we do need to do that. Is this Bill? This is your answering Josh here. I think of the designer as the owner of the route and the fabricator, assembler, the implementer. Yes, you're spot on there. Andy, in my project, there are a few subcontracted hires by contractors as a fabricator with spool. Yeah, that can happen as well. Yeah. And Bill's response, with guidance from their supervisor, shouldn't piping designers be required to read and understand the client's specs and standards? If so, at the beginning or on the, yeah. So let me talk about that very briefly. When a new project is conceived and a new client is on board, there are so many new clients these days, it's hard to keep up with the brand new companies that are out there buying up facilities. And I'll give you one example. There's a company called Ineos, which we may have all heard of. Now, Ineos don't have their own specs. They rely on a engineering contractor like a Fluor or a Worley or a KBR or a Wood. They rely on that company to use their own specs, because what they say, well, what's the point of us producing the specs when we've got an engineering company that could use theirs? So that's fairly common these days as well, for a client-based operator to say to the engineering company, we'll use your specs. So comment here from Satrio. You said normally piping engineers are made to be a draft that design and layout. It is possible right now that piping engineer become piping inspection, because in my college it has been erased from my subject lecturer, and there are many codes and standards right now. Yeah, great point. And standards right now. What do you think? There is a margin code, and from different code there is. Yeah, so I agree with you. That yeah, engineers often, I don't see too many piping related engineers, true engineers that want to move into inspection, but they do, because inspection is a construction based position of employment, and often engineering folk, they're happy to do their bit in the office, or these days working from home and office based in a joint setup, but construction people, yeah, there are lots of people that want to, they prefer to be part of a construction team. So yeah, I can see that. I can see that happening. Clarence, another one from you, mate. Piping designer using automated systems to ensure that the RDB database is set up to create isometrically meeting project scope. Field exposure is vital to the strength. Very much so. So just a word on what Clarence is writing then. One thing, at the end of my apprenticeship in the late 70s, they sent me up to site for 6 months to work on an olefins plant. So that was a great experience. I mean, they set me up with some practical jokes as well in those things that I was glad to be shot off. So one day, my piping lead asked me to go to the material warehouse and ask him and ask for a long wait. Well, as a young piping guy, I didn't know what he meant by a long wait. And when I went into the materials and asked the guy and asked him for the long wait, he said, "Just that's fine, Mitch. Go and sit over there, and we'll get it ready." And an hour and 3/4 later, I realised what a long wait was, and they'd set me up. And so it's important to have that site experience, to understand what went right and what went wrong, and you only have to walk around a facility that's not been laid out well and realise how much insufficient maintenance space there is. Valve hand wheels that are 8 feet up in the air without any chain operators on them. Tripping hazards on small bore small bore piping coming out of a pump into a drain, and because the pipe into the drain is right in a walkway. So these things are important. So great point there, Clarence. Good point. Satrio, a question. Oh, that's Bill's response there, whether piping engineers will be satisfied with piping design. I can see them going into piping and equipment inspection, which will be a mixture of design and yep, absolutely. Can't disagree with that. Yeah, good. Some good comments there from everyone there. Terrific.
I think we also should point out that Mitch, your experience has been on large and very large projects. And there may be some people who find work for smaller companies that are doing brownfield work.
Yeah.
Which means small revamps. And these companies may not have big, huge, comprehensive standards and specifications. The client may not even have piping specifications. But everything applies if you're talking about large scale projects. Because someone was talking about who's responsible for the isometrics. In some cases, when you have a really small project, you don't have a team to create the ISOs. So you may be making a model, give it to the fabricator, and then it's field build, you know.
That's absolutely right, Paul. You're spot on there. You'll get there'll be jobs, and I've got involved in jobs where there would be 500 man hours to complete an entire project, and I'm on my own. And I've got to do it I've got to do it in 3 months or whatever, and finish this, which includes a site trip. So you go out to site, you make sketches, you come back. There's no piping drawings. All there is are markups from a process engineer on some line on the piping that needs to be installed, and you've got to take all that and then talk to a fabricator, and you drawing your own ISOs and drawing your own sketches. Take them to get built, and that's all done very quickly. Yeah, no, you're absolutely right. Great point. They're not all big projects. Yeah, and often those smaller ones, they go very well indeed. When you find people that are under pressure to produce something, and they have to come out with the goods instead of having a long time, often people will shine on that with the right person in the position. Yeah. So good. Yeah. Spot on, Paul.
Do you see any other questions in the chat?
I don't see any more, but these have been great questions. I mean, I must say I will add something in the book that I talked about. There are lots of examples of where projects have gone wrong and why, and projects that have gone well. So there are, take some heat from if that helps anyone on this call. But yes, great.
I like the section on. I did read the book. I finished it a couple of weeks ago.
Oh, okay, good.
I like the section about telling the truth when it came down to how much progress you have for the mod reviews.
Yes.
You're under pressure to say, "Oh yeah, we're 70%," so that you can get the manager can get the bonus, but you're not really 70%. But
no, that's right. That's it. It's all tongue in cheek. It's ticking up, and in truth, over the years, if I'm in that sort of position, I don't know why I would come out and say this, but you tend to know what you should be putting down. It is, and it's not always legitimate. You've got to put down what's right without overstretching your own team. There's ways of doing that, of course, but progress is one big subject. Yeah, it's great. There's a question. I think Catherine's put a message in here. Thanks, Catherine. Anyone that's posted their email address, it's not always clear the name of that person, so follow up with the full name. I think that's what you're asking there, isn't it?
Yeah, that's a good idea.
Correct. Thank you. Yes.
No problem at all. Yeah, great.
All right, so we're coming up on to an hour now. We'll leave the chat open, I guess, so that people have time to put in their names attached to along with their email address. Do you have any?
Mitch, I've asked a question about how essential are drafting skills and knowledge in our era of 3D modeling. Should we even train people to be drafters anymore? For example, should you learn one-line piping symbols and all that nomenclature? I mean, how essential do you think that is now to a newbie, that they be versed in drafting techniques?
Do you mean manual drafting techniques, Bill, or
Yes.
CAD?
Yeah, I mean,
Yeah. Oh, that's
constructing a third view from two views and so on, the old drawing board stuff.
yeah. I mean, there's a guy. Do you remember Alan Smith, Clarence? Probably
Yeah.
do. Yeah. So he was. I was when I was 16. I worked alongside Alan Smith, and he used to turn out these works of art, and of course we had these Pentel pencils that had various thicknesses of lead. So for the very small bore piping, he would use 0.5 of a millimeter width. For the middle size ranges of piping, like 8 and 10-inch piping, he would use 0.7, and then for 12-inch piping, he'd use 0.9 millimeters. So his drawing, you could see when you looked at that drawing, you would know exactly what size piping, where the big thicker piping, the larger bore piping was. But Bill, to answer your question, I don't think so. I don't see a need. I mean, I don't see a need for people to be trained in understanding the nomenclature and all that. Maybe they'll pick that up when they're on their apprenticeship, if they're on an apprenticeship, when they're reading process flow diagrams, for example. But for example, on piping drawings anymore, I used to get pulled up because I would not put my weld dots on the piping GA, and the little black dot on a piping system around 2 elbows, 2 dots that represent the welds, because you could count the weld. You could do a weld count on the piping GA. Then you might remember that, Clarence, Kev,
Yes.
right? Doing things like that. So, but now to train people with that, Bill, I'm not so sure, to be honest. Maybe not.
I guess with AI technology, we have advanced to a degree where when we look at it, when I mentioned the RDB database, it is critical to any project, especially in large corporations, because without that setup, a designer cannot really put in a line pipe size with the components and with the reference to really have an effective deliverable. When we look at manual drafting, the designer has to have the experience in terms of understanding the fundamentals, which SPED is a key player in the fundamentals of what a really piping designer does. We are enriched with a value that we have to collaborate with all different levels of the silos that encompasses what we do as a designer. The values of this also with site experience enriches us to be more proficient, even to support the engineers in some cases. I have had cases where I go on a site with an engineer, he wants to know what a spec line is. And I'm saying, if you are an engineer and you don't know what a physical spec line is and have to show you, that shows the lack of. And as a piping designer, these fundamentals are very effective in the values and the lessons learned we take from one project to the other.
Yeah. No, spot on, Clarence. And sadly, that is happening. You wouldn't have seen that 40 years ago, but people are getting sent to site now without any training and without any understanding of what they're looking at. You're right, absolutely right.
Yeah, the software tools has enabled engineers to be obsessed with schedules and budgets and not know what a spec line is.
Yeah, exactly.
Because all they're doing is counting hours and who did what when and are we on track.
Yeah.
That's all.
To be a successful designer, my take on it, if you design a facility and it's up and running within 2 years, you can consider yourself a successful designer in terms of for the operations to really minimize the cost. If you do a design where you find that after commissioning, your operating costs on that design is increased because of deficiencies, you realize there's an oversight, and basically the engineer has to really review to see the full competency of the designs. So these are lessons we have to learn by in terms of what are deliverables, how they are made, what minimize the deficiencies to avoid cost overruns on the project if you can. But at the same time, we have to look at exactly what are the principles and the fundamentals we have to ensure your name and reputation on the project as a designer is of value.
Spot on. Absolutely right.
Okay, do we have any more questions on the? I think Bill has a current training programs question.
Well, I asked in current training programs how much IT training should be required. Microsoft Office, AutoCAD literacy, solid modeling, database concepts. What would you recommend that a newbie be trained in before he shows up at a company to work?
Great point. As a designer, you mean, Bill, or an engineer?
Designer, somebody that wants to go into 3D routing, equipment layout, and so on. Well, what would you say? Obviously, you should be AutoCAD literate. But what about 3D solids modeling? Should that be in the curriculum? What about Microsoft Office? Should that be in the curriculum? Should they learn about databases?
Yeah.
What should they learn about?
I think, great point. So if you're talking about the piping knowledge generally, I think so. The graduates that Worley have taken on recently, they all did courses in mechanical engineering. So you don't get too many courses in piping engineering outside of an apprenticeship, and you don't get many apprenticeships either. But you can find mechanical engineering courses, and these two individuals that work closely with me now, they came off a mechanical engineering course, a 3-year full-time course, a degree. They actually degreed, and they decided within that mechanical course that they wanted to be pipe stress engineers. So they've joined the company. The company took them on as mechanical engineers to finish, and they finished their degree while they were at the company. But they both wanted to move into pipe stress. So that's an example there. So to answer your question, Bill, in a long-winded response, there is mechanical engineering would be the stepping stone to get into a company to move toward the piping.
Well, I'm thinking of designers, layout and equipment layout.
Yeah.
They should be AutoCAD literate, should understand AutoCAD. Should they need Microsoft Office? Yeah. Should they be taught, say, SolidWorks or some kind of a solid modeling? What should their background be in terms of IT skills that they can apply in the future? Because, we use these IT skills in viewers, we use it in 3D routing. Now we all route in 3D rendered space instead of, the old wireframe. It's all changed. Yeah. So what would you recommend as a background? If you wanted to be a designer, what should the IT content be?
Yeah. So as a minimum then on that side, the only thing is if you're going to learn AutoCAD, you're going to spend a year maybe doing an AutoCAD or a MicroStation course, but you're not, in truth, you're not going to be taught the piping stuff, the crux of the piping. That's the downside of that.
If I could just interrupt for a second,
please.
That's where we end up into the silo problem, where you have AutoCAD Plant 3D, you may have PDMS, you maybe have SmartPlant, you may have CADWorks, And if you take a general AutoCAD course in preparation for learning piping, you may learn things that you're going to have to later unlearn because you're going to have to use the specific commands that exist within, let's say, CADWorks or Plant 3D and not vanilla AutoCAD.
Right.
And the same thing goes for if you're using the big iron software like PDMS and SmartPlant. Well, these are serious. You're going to be learning that for a long time because they're big and complicated. They require a lot of admin and CAD support tech.
Very much.
So if you go in and you learn generally about solid modeling before you jump into piping, it may not. The concepts will apply.
Yeah.
The specifics about how to do things, you may have to unlearn them and then relearn how to do them with the specific software that you're going to be using when you finally start working.
I mean, are there courses, Paul, are there courses in Canada on E3D, for example, true piping 3D modeling and design? Are there courses outside of an engineering company?
Kevin could probably answer that. He actually took some courses. Kevin,
years ago there were, but I don't know about these days.
I think Kevin maybe he's walked
a
away.
lot of the people attending today are from a program in Indonesia, PPNS in Surabaya, and they have a program of about 100 students who study piping. I wonder what they think. Did they get solid 3D SolidWorks or 3D solid CAD training in their curriculum? And if so, did that seem useful later? Well, let's see.
Maybe not.
I don't know. I did ask another question about where are jobs? Where do people find jobs now? Since we're all worldwide, we're working worldwide. Where do you go to find the job? Does a recruiter call you, or do you get a call on LinkedIn? I mean, how do people find other pipers?
I can give you my thoughts on that. So first of all, if you've been in the business a while, you normally got people that you can fall back on, and you can call Jim up at a company and say, Jim, this job's finishing next month. Are you looking for any people? You're working at Fluor at the moment. Are you looking for any people? He said, yeah, you know what? There is a project that are taking on. I can put a word in for you. So that's one alternative. LinkedIn is a huge opportunity. I would encourage people to go on to I'm on LinkedIn. I find it's a great network for people in this business. But also at the end of the day, write to the engineering companies, write to the human resource department, and address your letter to the director of engineering, and that will get some. And especially if you're qualified and if you've got that degree in mechanical engineering or process engineering or whatever you've taken the degree. But by all means, look up these companies. You can go online and look at oil and gas. If you Googled oil and gas engineering companies, you'll get enough companies that pop up for you to keep you busy preparing letters. But yeah, usually these days you can prepare a resume, send an email to a human resource department of a company, but always ask for that engineering director, because then they'll move that forward, because an engineering director he'll need to take people on, because all these engineering managers on projects are desperate to have a piping guy on board somewhere, so that it's in their own interests. Yeah, if that helps, Bill.
You know, Mitch, I found one of the issues with software specialization is that companies that will only hire people with special skills in those softwares. And what that does is isolate cohorts of technical people that can sort of move as groups within those companies that use those particular softwares.
Yeah, that's a good point as well.
Yeah,
No.
and previously, when we were drawing by hand, I know it's redundant information now, but you would have a lot more movement between projects and different companies. So knowledge gained at one employer could be carried over and used at the next employer. So it was much easier for the whole group, overall group of piping designers to share knowledge, to teach each other, to show each other information. Whereas now, like Kevin said, if you start in E3D, you probably won't be considered for a smart plant project. So you'll never meet those people who are in that
No.
other silo, right?
Yeah.
So you
Yeah.
have you really are in a silo is enforced by the software that's used by that particular project. Or
Yeah. Yeah. And always on your resumes, when you're applying for a position and you've used one or just one system, always add something that says, say you've used Smart Plant 3D. So you've been doing that for 5 years, but you've not done no other system. So in your resume, write down literally, I've worked for several years with SP3D, but can be familiar with E3D, PDMS, CADWorks. Get those names on the resume, because these days algorithms they look through a resume, and in truth, if someone's worked on Smart Plant 3D, it will only take them a week to get up and running on an E3D system. So they shouldn't write themselves off by not putting those down. It gives you another opportunity. It's my thoughts anyway.
Yeah, you're referring to the applicant tracking software
Yeah.
that the human resources department use to scan your resume. If they
Yeah.
don't see that magic word,
Yeah,
it doesn't get to the guy who makes the decision about who gets hired.
that's exactly
So if you put
exactly
in
right.
there, so like Mitch said, if you put in there can easily learn, and then you list all those
Yeah.
software packages, then your filter will see, oh, it says that in the
Yeah.
move to the next.
Exactly right. And you're being honest on the resi
Yeah.
by saying that you've had, you've had limited exposure and you're familiar with these systems. That's all. That's all you. But then because in truth, I've had guys that have called me good piping guys that are looking for a position, and we need someone like that on the project I'm leading, and I'll say, oh, don't worry, start Monday. You'll be able. We'll give you some time. You can work a couple of evenings on the system. That they can pick things up if they've got the piping knowledge in the first place.
And you get the piping knowledge from SPED.
And you get the piping knowledge from SPED. Yeah,
Since
absolutely.
since in-house training now is a rarity for the most part.
Yeah. Yeah, what does this say? Since designers are now gypsies, how do designers find their next job? Yeah, that's what you were just asking. And Kevin, Keywet is a construction engineering company that focuses on giving new engineering designers solid field experience. Yeah, that's good to hear. These courses then can only work for companies that specialise in particular modelling software. Absolutely. And then the last question I'm seeing here is English the only language you need to know as a piper? So I must say, every project I've worked on overseas has been in English. That didn't go down well in Montreal, Paul, on the Hibernia project, when we employed a lot of French Canadian resources, and they were going, why don't we have a dual French and English? Well, it was impossible to do that. It was in English, but yeah, I think is there a lot of work in Arabic, Spanish, Chinese? I think from a technical point of view, people do need to understand the English side of this industry. I might be wrong there. I'm fortunate because I was brought up with a Anglophone background.
A lot would depend on which standard you're using, because you're using JIS or the European EN standards. But if you use ASME, then
I think there was a question in the chat box about that.
Yeah.
In my experience, working in Quebec, my experience is that many contractors prefer to see the documentation in English because there's no direct translation for these technical terms, right? So it opens a door to confusion and, ordering or installing the wrong piece because,
Right. Yeah.
You mentioned Quebec. Kiewit has an affiliate in Quebec called Ganatec, and they do all their work in French.
Oh yeah, I've seen Ganatec, and I thought they were associated, but
Okay, and it's all local work, I take it, Kev, right?
Yes.
Yeah.
Okay, so Mitch, can you give a kind of like a summary of your book, like an overview of the beneficial and detrimental changes you've seen over the years, over the last 50 years in this business?
Yeah, sure. I mean, so a couple of things there, Kevin. I put a link further up to the book on Amazon where you can see it. And Amazon have actually got an introduction on there. So I'm going to steer that question towards that because that is a 15-page summary of what the book's about. So you'll get, and it's a freebie. So you'll get out of the 317 pages, 15 of them are free. But those 15, I was a bit worried when they put 15 pages on there. I thought, blimey, no one's going to ever read this book, but it's a summary of what you're asking actually. So it would help people, but generally, in a nutshell, the changes from drawing boards to CAD and outsourcing and the cultural aspects and the fact that, when I was growing up and when I was an apprentice, we had one woman in the project team and she was the secretary. And now on projects, we might have out of 50 people, 30 of them might be females working on the project. So a fantastic transition there and of what we've seen. So the book's all about stuff like that. But the introduction on Amazon, you'll get a good summary of what it's about.
Thank you, Mitch.
Okay.
Very, very interesting.
yeah, I guess we're coming close to an hour and a half. So I guess
it's good. A very, very great conversation. This. Very good, Catherine and Paul.
I really enjoyed the book. I recommend it to everyone who works in this field. And I really enjoyed this conversation.
Yeah.
Thank you, everyone, for showing up.
Fantastic. Kevin, Clarence, great to see you guys again. And as usual, that's I'll never forget that smile, Clarence, you have, mate, there. And to everyone here on the call, I thank you and thank you, Paul and Catherine and Bill, for inviting me to be part of this.
Okay.
Thank you, Mitch. Thank you, everyone, for attending.